right, today we're going to talk about HL and CPCTC. You probably have no idea what those mean, so let's go ahead and get started. First things first, we've talked about 4 different methods that we can use to prove triangles congruent. Before, we would have to list out all the corresponding parts. We would have to list out the 3 angles that were congruent to the other 3 angles in the other triangle. And then we also had to list out the 3 sides that were congruent to the 3 sides in the other triangle. That's a lot of work, right? So some brilliant person discovered that there are theorems we can use if we have not as much information, or if we're lazy and we don't want to write out all the 6 parts. So let's go through those theorems now. We have side, 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 right? Angle, angle, side, side, angle, side, and angle, side, angle. So these are the 4 that we've already talked about, and today we wrap it up with our last one. We kind of leave him to the end because he's a little weird. There's a 5th method to prove triangles are congruent, and this method works for right triangles. Okay, this only will work for a right triangle, and it is called the hypotenuse leg method. It's called the hypotenuse leg method. So HL, right? Hypotenuse leg, HL. Notice that it only works with right triangles. Okay, this is really important. You have to make sure you have a right triangle. You gotta have a right triangle. I can't say it enough. It's on here so many times because people forget, okay? So you have to have a right triangle. So let's go ahead and check this stuff out. So down here, see these 2 triangles here? Let's go ahead and label them like I've said in class we should do. So we should write an A next to every angle, and we should write an S next to every side. And then we should circle the ones that are actually marked in the picture. Alright, so we don't go this way. Now, before, we would just say what letters are here. And what this looks like to me is the booty theorem. Okay, so there's not a booty theorem, right? We said that we cannot use ASS or SSA, whatever way you want to look at it. Some people call it the donkey theorem, whatever. You can't use it, right? And we're labeling sides and we're labeling angles. We're never going to have an H and an L in our picture, right? So look at your picture. Is it a right triangle? Yeah, this guy's a right triangle. I see it right there. It's a right triangle. So anytime you get the booty theorem and it's a right triangle, this guy is going to be HL, okay? So anytime you get the booty theorem combined with a right triangle, it's going to be HL. So with that being said, let's match our stuff up. R goes with what? H. I goes with what? T. And then the last one must be S. So what I would like you to do, actually no, I want to go over this one because this is what a lot of people miss. Let's check this one out. So we have angle, 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 side, 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 circle, circle, circle. Okay, so we want to go the shortest distance, so that's our dead end. So if I go around, you'll see again this is the booty theorem. However, is it hypotenuse leg? You should be looking to see if it's a right triangle. Is it a right triangle? No. So it's not HL because it's not a right triangle. Okay? It's not a right triangle, so it's not HL. So guess what? You can't do this. You can't tell me they're congruent. Please don't tell me they're congruent when you don't have any theorems to say they're congruent, okay? So you cannot do that one. That one is a no-go, all right? So let's move down here. What method, if any, is being used to prove that the triangles are congruent? Hint, it might be easier to break those triangles apart. Mark those shared sides, mark those vertical angles, and there's one other thing I talked about in class. If you have parallel lines, make sure that you mark your alternate interior angles. Okay, alternate interior angles. So let's look at number 1. Does it have a shared side? Sure does, right there. I see it, okay? So it does have a shared side right here. I'm going to use blue. And does it have any vertical angles? No. Does it have any parallel lines? No. So let's break that triangle off, and I'm noticing that there's a 90-degree mark here, this is marked here, and this is marked here. Correct? Alright, so with that being said, let's do our A, S, S, S. And let's circle what we got. We got this, we got that, we got this. We're going to go the shortest distance, so let me cross those guys right there out. So look at this. To me, it looks like ASS. It's the booty theorem. So you have to ask yourself, I've got the booty theorem, but is it a right triangle? It is, right? So you've got the booty theorem. It is a right triangle, right? So the method that you're proving this with is hypotenuse leg, HL. So HL always goes with the booty theorem. So then we're going to look at our picture. We're going to match things up. What does F go with? Well, if you're having a hard time here, you could also break up your triangles like this. So L, F, I, this, this, this. And the other triangle we have here is this one. And this is F, I, P. So looking at this, what would F go with? F has that 90-degree angle in the first triangle. What has a 90-degree angle in the other triangle? An I. Let's look at L. L has no markings on it, right? What has no markings here? Well, both of them, right? F and the P. Well, we have to look. L is in between the 90 mark and the 1 mark. And the thing that's between the 90 mark and the 1 mark here is P. Then let's look at I. Well, he must go with the last letter we haven't used in our second triangle. So that's going to be F. Okay? So I would like you to try number 2 on your own. So this one is for you to try and bring to class. You can pause it now and do it, or you can do it later, whatever works. And then let's go ahead and let's go over here and let's look at number 3. So on number 3, do we have any shared sides? No. Do we have any vertical angles? Yes, right here. So these must both be 90. Do we have any parallel lines? No, so we're good there. Okay, so with that being said, now we're going to mark all of our angles. So angle, 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 side, side, side. This is marked, and this angle over here is marked. Okay, so if we go the shortest way, we would go like this, and it would be ASS. Now, it's ASS, but is this a right triangle? Yeah, it is. It is a right triangle, so we're good. Hypotenuse leg proves that these two triangles are congruent. What I'm going to have you do is fill out what this goes with, because that we've practiced already, so I'm going to have you fill that out. And then I'd also like you to try 4 on your own also. So try 4, bring it to class, okay? So be careful with them. Make sure you look for your parallel lines, your shared sides, your vertical angles. So let's move down here. Again, 5 methods to prove triangles congruent. What are they? Well, we just talked about HL. We've also got side, side, side. We have side, and angle, side, angle. And the last one is angle, angle, side. 2 that don't work. Please don't try to use ASS or SSA, okay? Those are the 2 that you cannot use. These 2 hint back to HL, okay? So as long as you have a right triangle, they will turn into HL, all right? Remember, if I'm going too fast, you can pause the video and you can write down what you need to write down. You can rewind it, you can re-listen and re-watch too, okay? This is all at your own pace. Moving on, once triangles have been proven congruent by one of the above methods, then we know that the rest of those parts are also congruent. So what am I talking about here? Let's go back to one of these pictures. Let's go back to, let's go back to this guy right here. Okay? So looking at this guy right here, I see that this angle goes with this angle, right? And I see that this goes with this, so we're cool on that. And then I see this goes with this. However, T and I go together, correct? But they're not marked. Well, we said that the 2 triangles are congruent, right? So if the 2 triangles are congruent, then T and I are also congruent. Okay? That's CPCTC. Corresponding parts of congruent triangles are congruent. What else did we not mark in the picture that we know now is congruent? These 2 guys, right? We know those are congruent now because we said the triangles are congruent. What other piece have we not marked? And that's going to be this guy right here with this guy, okay? So you'll always have these 3 pieces left over that you are going to list out for CPCTC, all right? So you're going to always have 3 pieces left over that you've listed out, that you've not marked, that you're going to list out as CPCTC, all right? So let's write down what it actually means first. Corresponding. And you're going to have to know what this means by heart, by the way. Parts of congruent triangles, I'm lazy, I'm drawing a triangle, are congruent. How about that? Corresponding parts of congruent triangles are congruent. If you think about what it means, it's easy to remember what it means. Like, if you think about its meaning, Corresponding parts, which we talked about earlier in class, they're congruent to each other as long as you have found that method and you have said the two triangles are congruent. Okay, so let's go down here. Some examples. Always mark shared sides and vertical angles. So you always want to do this first, and don't forget, sometimes there's also alternate interior angles that you can mark. Okay, so let's go ahead and see. Are there any shared sides? No. Are there any vertical angles? No. Are there any parallel lines that give you alternate interior angles? No. So we're good. So we're going to go ahead and we're going to write A next to every angle and S next to every side. And then we're going to circle the letters of the things that are marked. This is marked, this is marked, this is marked. So don't go this way, okay? That's the long way. What do you have here? SAS, and that is a method. So we're good to go. So now that we know we have SAS, now we have to figure out what our congruency equation is going to be. What does P go with? P goes with F. And what does A go with? Well, A is between this 2 mark and the no mark. Does everybody see that A is between a 2 mark and a no mark? And here, a 2 mark and a no mark would be right here. So R would be who he goes with. All right, so A goes with R. And then we have one left. Y. Oh, I said A goes with R, and I totally wrote an A there. Whoopsie. There we go. Pan fry. Okay, cool. CPCTC. So this is the new stuff right here. Here's what it's asking. What did you not circle? What did you not circle? It's the stuff I crossed out, right? Aren't these the dudes I didn't circle? Okay. So if these are the ones that I did not circle, then these are the ones that are CPCTC. So let's look at this. So this angle right here would be angle A. And what does angle A correspond with in the other triangle? It corresponds with angle R. We know those are congruent because both triangles are congruent to each other. And then the next one was the side. What side is this? It's side AN. What does side AN go with? AN goes with RY. So we know those are congruent since the triangles are congruent. What's this angle go with? Angle N. What does angle N go with? Y. Okay, so we know these are congruent because we said the triangles are congruent. So basically it's your leftovers. It's your guys that you didn't circle when you first found out what method you're using. Okay, so I would like you to try number 2 on your own. Try number 2 on your own. And number 4... go ahead and try that one on your own too. We can talk about it in class. You've seen one example. Why don't you go ahead and try these 2 on your own? Hey, if you don't know how to do them, I want you to go back and rewatch this. Some of you just write everything down and you're not actually listening to me. And that's what's great about flipping. Now you can write it down and then you can go back and actually watch what I do and understand what I do. Okay? Down here, I definitely want to talk about these in class, so you can try them if you want, but you don't have to. I am going to go over them in class. I mean, if you want to, it's kind of nice, because then you'll know if you know what you're doing, so I encourage it, but you don't have to. Okay? So, I will see you in class. Have a fantabulous night.